For this problem, we want to find the area moment of inertia of this shaded area about the x-axis. Okay, and the way we're going to do this, we're going to break it up into three pieces as shown here. I've got a little square down in the lower left side. I've got a big triangle right here, and I've got a little triangle right there. Okay, so what I need from them is the area and the location of the centroid for each one. So for the square, it's just going to be halfway up, which is going to be 1.5 inches, 3 divided by 2. Okay. For the small triangle, it's 1/3 of the height, which is 3. So from the base of the triangle up to here is 1. Okay. But then I have to add 3 from the x-axis, so that's where the 4 comes from. And then my big triangle here is going to be 1/3 of the way up. It has a height of 6, so that's going to be 2, because 6 divided by 3 equals 2. Using that and the parallel axis theorem, which is the moment of inertia of each shape about its centroid, plus the area times the distance away from the centroid to the axis of interest, which is what I talked about here with the 1.5, 4, and 2 squared. Okay, so start with the small triangle. Looking up in the back of the book, the moment of inertia about its centroid is 1/36 times base times height cubed. So 3 by 3 cubed. Okay, plus the area, which is 1/2 base times height, 3 times 3, times the distance away squared, which again is that distance of 4 from the centroid of the small triangle to the x-axis. Okay. For this square, which I have right here, is going to be 1/12 base times height cubed. Okay, so 1/12 base is 3, height is 3 cubed. Okay, plus the area of that, which is just 3 times 3, times the distance away between the centroid and the axis of interest, which is just 1.5. You square that. Finally, the big triangle is again 1/36 base times height cubed, and the base is 6, the height is 6. Okay, and then add the area, which is 1/2 base times height, times the distance away squared, which again is 2 given here. So plugging all that into a calculator, you get the answer of 209, and that is inches to the 4th. And again, what we're doing here is just the parallel axis theorem. The moment of inertia about its centroid plus the area times the distance that centroid is away from the axis I'm interested in squared.